Welcome student to our new lecture. Topic name is displacement current. Already you know DC and AC currents, alternating and direct currents. यामध्ये आता हा डिस्प्लेसमेंट करंट इट इज ऑल्सो इन शॉर्ट DC हा डायरेक्ट करंट आणि अल्टरनेटिंग करंट पेक्षा थोडंसं वेगळं आहे. काय आहे ते कन्सेप्ट आपण आता स्टडी करणार आहोत. आपल्याला माहिती आहे व्हेन DC करंट इज फ्लोइंग थ्रू अ सर्किट, electrons are flowing across the direction of current. Means electrons are accelerated towards the positive terminal of the external source connected across the network, across the component, resistance, any component. In this figure, a DC source, battery or cell is connected across the capacitor with dielectric material. In the conducting part of the circuit, free electrons are responsible for the flow of current. But in the region between the plates of capacitor, there are no free electrons available for the conduction in dielectric. As the circuit is closed, the current flows through the circuit and the electric field rises at the edges or plates of the capacitor. Due to the rise in current, means the current is flowing through that network. As the value of current increases, the electric field is produced, and that electric field also increases at the leads of these two capacitor plates. That conduction current IC is found to be same everywhere in the circuit except inside the capacitor. As the current passes through the leads of the capacitor or plates of the capacitor, the electric field between the plates increases, and this is in turn causes polarization of the dielectric. This dielectric material is polarized. Means there is a current in the dielectric due to the movement of bound charges. The current due to bound charges is called as displacement current or charge separation current, noted as I suffix like ID is the displacement current and IC is the, here dq upon dt is the conduction current IC in the conducting part of the circuit. Therefore, above equation becomes IC is equal to dq by dt is equal to a k epsilon 0 dE by dt. Therefore, dE by dt is equal to IC by a k epsilon 0. Means rearranging the above equation we get dE upon dt equal to IC upon a. Thus the displacement current is equal to a epsilon 0 dE by dt. If a and epsilon 0 are constant, then ID is directly proportional to dE by dt, or the rate of change of electric field is directly proportional to displacement current. Now the conclusion of this term displacement current. A displacement current exists at any point in the space where time varying electric field E exists. That is, dE by dt is not equal to 0. Means rate of change of electric field is not equal to 0. Our next point is energy stored in the capacitor. Consider the diagram which contains one capacitor connected across the source with potential difference V. Now what happens when a charge is flowing through that circuit? Means the capacitor gets charging. Capacitor charges means the work is done against the capacitor plate. A capacitor is a device used to store energy. Means charging a capacitor is nothing but the transferring electron from one plate of the capacitor to the another plate. Hence work will have to be done by the battery in order to remove the electrons against the opposing forces, and these opposing forces arise since the electrons are being pushed to the negative plate, which repels them, and electrons are removed from the positive plate, which tends to attract them. In both the cases, the forces opposes the transfer from one plate to another. As the charges on the plate increases, opposition also increases, and this work done is stored in the form of electrostatic energy in the electric field between the plates, which can discuss by using this diagram. Consider the capacitor with capacity C and a source of energy with potential difference V. Now by definition of capacity, C is equal to Q prime upon V. Q prime is the instantaneous charge if the capacitor is charged at any middle instant during the process of charging. Let Q prime be the charge on the capacitor and V be the potential difference between the plates. Therefore, C is equal to Q prime upon V. Now consider a small amount of work is done if a small charge dq is further transferred between the plates. Therefore, dw is equal to that small work done is equal to V dq. V is equal to, from above equation, V is equal to Q prime by C. Therefore, that small work done dw is equal to V dq or Q prime C dq, Q prime upon C dq. Now, the total work is, that above equation is for the small work done due to the small charge dq. The total work during the charging of capacitor is W is equal to integration dw, which is equal to integration 0 to Q prime by C dq. Therefore, W is equal to 1 by C integration 0 to Q prime dq, or W is equal to 1 by C Q prime square by 2, which is the integration of Q prime dq, means integration x dx is x square by 2. Like this, Q prime square by 2, limit varies from 0 to Q. Using the limit values we get W is equal to half Q square by C. Thus, the total work done during the charging of capacitor is W is equal to half Q square by C. Now, this work done is stored as electric potential energy of the capacitor, and therefore that work done can be expressed by the following terms. Since Q is equal to CV, therefore the equation becomes W is stored in terms of energy is denoted by U is equal to half Q square by C above term. By using Q equal to CV, we get U equal to half CV square, or U is equal to half Q into V. This is the expression for energy stored in the capacitor. And the next and last point is 1D Graaff generator. This is the schematic diagram of 1D Graaff generator, and the terms are explained in the side of that generator. Now we discuss about that generator. First see the principle, then we discuss about the construction and the working. What is the principle of 1D Graaff generator? This generator is based on the phenomena of corona discharge, means action of sharp points. The property of that charge given to a hollow conductor is transferred to its outer surface and is distributed uniformly over it. And if a charge is continuously supplied to an insulated metallic conductor, the potential of the conductor goes on increasing. आता आपण थोडंसं त्याचं कन्स्ट्रक्शन आणि याच्याबद्दल थोडं डिस्कस करूयात आपण. 1D Graaff जनरेटर हे जे डिव्हाइस आहे हे जनरली कशासाठी यूज केलं जातं? टू डेव्हलप अ व्हेरी हाय पोटेन्शियल ऑफ द ऑर्डर ऑफ 10⁷ व्होल्ट्स. The resulting large electric fields are used to accelerate charged particles, for example, electrons, protons, ions, to high energies, and needed for the experiments to probe the small scale structure of matter or for various experiments in the nuclear physics. First we see the construction. What is the terms which are given here? P1, P2, B, A, C, D, E. Now discuss in details. And endless conveyor belt BB, in seen figure BB is shown here, made of an insulating material such as reinforced rubber or silk, can move over two pulleys P1 and P2. Means P1, P2 are the pulleys and BB is the belt. That belt is moving over that pulleys with a motor. The spray brush A, consisting of a large number of pointed wires, is connected to the positive terminal of high voltage DC power supply. From this brush, a positive charge can be sprayed on the belt, which can be collected by another similar brush C. Means A is the emitter brush and C is the collector brush. This brush is connected to a large dome-shaped hollow metallic conductor D. Means that collector brush C is connected with dome-shaped metallic conductor D, and that conductor is mounted on the insulating pillars. Now E is an evacuated accelerating tube having an electrode I at its upper end, and that electrode is connected to the dome-shaped conductor. Means the electrode in evacuated tube is connected to the dome-shaped conductor D. To prevent the leakage of charge from the dome, the pulley and belt arrangement, the dome and a part of the evacuated tube are enclosed inside a large steel vessel S, which is filled with nitrogen at high pressure. Now see the working of that 1D Graaff generator. The electric motor connected to the pulley P1 is switched on, which begins to rotate, setting the conveyor belt into motion. The DC supply is then switched on. From the pointed ends of the spray brush A, a positive charge is continuously sprayed on the belt. That belt is moving over the pulleys P1 and P2. When charge is sprayed over the belt, that charge is carried from point A or brush A to brush C. A positive charge is continuously sprayed, which is carried from brush A to brush C. Therefore, that charge is collected by the collector brush C and sent to the dome-shaped conductor. As the dome is hollow, the charge is distributed over the outer surface of the dome. Its potential rises to a very high value due to the continuous accumulation of charges on it, and thus the potential of the electrode I also rises to this high value. Now the positive ions such as protons or deuterons from a small vessel containing ionized hydrogen or deuterium are then introduced in the upper part of the evacuated accelerated tube where the electrode I is fixed. These ions are repelled by that electrode I and accelerated in the downward direction due to the very high fall of potential along the tube. These ions acquire very high energy. These high energy charged particles are then directed so as to strike a desired target. Means that 1D Graaff generator generates a high energetic positive particles like protons or deuterons, and thus the uses of that 1D Graaff generator are given below. The main use of 1D Graaff generator is to produce very high energy charged particles having energies of the order of 10 mega electron volt. Such high energy particles are used to carry out the disintegration of nuclei of different elements, to produce radioactive isotopes, to study the nuclear structure, to study different types of nuclear reactions, accelerating electrons to sterilize food and to process materials.